Hello and welcome back. In this video, we will talk about one of the very important microservices design pattern, and that's called the event-driven microservices. Well, before getting into the event-driven microservices, I will give you a total fundamental how the traditional microservices architecture works with the REST API, what problem we face over there, and why do we need to bring in some message broker like Kafka or RabbitMQ? What is the work of it? And then I will introduce the event-driven microservices and the challenges it solves. So to watch this video, you don't have to be a pro on anything because I'm going to do very simple coding. I will not complicate this. So this is going to be a beginner friendly video. So if you are new to Spring Boot and microservices and exploring different microservices architecture and design pattern, this can be a go-to video. So that's it. So we can get started right now. But yeah, one important notice here that I have used Kafka as a message broker here with this particular video. So if you are trying to understand what is Kafka and why you need to learn Kafka, then this can be a good starting point because this is going to showcase you the problem that the Kafka solves and what kind of benefits the Kafka can add inside a microservices architecture. So even though you are completely new to Kafka, this video will not give you any kind of confusion and will give you a solid idea that why Kafka is needed or why a message broker is needed. So without any information about Kafka, you can also get started with this video. So let's just get started, and don't forget to give me a thumbs up if you want to see more and more videos like this. It's a story about three friends. The first one is called a user registration service, which is a Spring Boot application, and it knows how to help a user with registration. The second guy, a email notification service, which is a Spring Boot application, and it knows how to send email to a specific user. And the third Spring Boot application named as SMS notification service, and its work is to send SMS to an user. Now, one day, these three friends received a business challenge. And here is the requirement. When a new user registers in the site, the user data will be saved to the database. The new user will get an email notification, and also a welcome SMS should be sent to the user. But here is the twist. Whenever a new user is going to come and going to hit our website for registration, the user registration service is going to first handle the request. But the user registration service only knows how to save the data to the DB. But according to the business requirement, the user registration means saving the data to the database and also sending email to an user and also sending an welcome SMS to the user. So now the user registration service has only option left to ask for help. So we will see how it will connect to its friend email notification service and SMS notification service, and how these people are helping the user registration service, and how all these three Spring Boot applications are solving this business need. We will see how they will communicate, what kind of approaches they are following, and what kind of challenges they are getting, and how they are resolving it. So let's begin. All right, so let's just try creating our first microservice. That's going to be the user service. So let's just go ahead and create our new Spring starter project. And I'm going to give the name over here as, let's say, user service, and choose anything, Java version 17 or maybe above. Type should be, let's say, Maven, and packaging type and rest of the things should be same. The artifact will be user service. Group ID will be com.selenium express user service. Okay. Rest of the things will be same as this. I'll just change the package name and I'm good to go. So let's just try to add some of the dependency. I will add the tape tools. Maybe I'll just search over here directly. And the second thing that I need over here is Spring Web MVC because I'll be creating a REST API in this project. So I'll choose Spring Web. And that's it. I'll just go ahead and do next, and I'll just do a finish. Now let's create the project, and there we go. That's our user service. So let's just go to the pom.xml just to verify if we get our things, and we got the dev tools and the Spring Wave. Okay, all good. Let's just get started with our project right now. First of all, I will go to my user service, and let's just go to source main Java. And right over here, I'll create a controller. So in this package, I'm going to create a new class, and the class name will be a user controller. And let's say I want to put this inside a new package called controllers, and I'll do finish. So right now, let's just go ahead and annotate this class with @REST controller annotation. So I'm going to say REST controller. And now let's just go ahead and create a method. Let's say public void and create user, because I want to create a user in this particular method. And I will just write some code over here for the user creation. Okay. First of all, as this is going to be a create user method, this is going to be a post method. So I'm going to say post mapping because I want to create a user. And here I want to give the endpoint as users. Okay. And right now I want to receive the user data from the client. Okay. So right now the client can send me the entire user data, like username, password, email, blah, blah, blah things. But right now, let's just keep this thing simple, and later we can enhance this more. So for that, what I'm going to do, I will just accept the username for now. Imagine the user will be created only with the username. So I do not want the client to send me all the information, just send me the username. Okay. So right now I can accept it with URL data only. So here only I'll ask the client that, okay, whenever you're going to be hitting this URL, give me the name, which will be dynamic for every request. And this is going to be my path variable. And let's just capture this. So I'm going to say path variable, and I'm going to say string and name. So make sure that this and this exactly match. Otherwise, the data that user will give through the URL will not be binded with this variable. Okay. So once we capture the data over here, imagine here, I'm going to do a DB call, and I'm going to save the user name. But this thing we will do maybe a little later. This is not the point how to save the username to the database. Maybe we can capture the entire user detail and save it in the database. But right now, let's hold on into that. The next thing that I'm going to be doing over here, once I'm going to capture the username, I will just say, I will just return the username. Let's say return, let's say user created. And the name of the user, I'll just concatenate and return it. Let's say name. And this is going to be a string. So I'm going to change the return type to string. Okay. So imagine this is my create user method. Okay. I'm going to capture the data, and I'm going to bind it to this. Imagine there is some DB call will be there to save the username to the database. We'll do that later. And then we are returning this. Maybe this is a post mapping method. So I'm going to use a response status over here. And the status for this method call is going to be 201 created, because this is a post mapping. Core, the HTTP core should be HTTP status dot created. Okay, there you go. Let's just try to test this out. Okay, so I will just go ahead and I will start my application. So let's just start the Spring Boot app. Let's just see if everything works good. And looks like the user service started and everything is good, right? And by default, the port number is 8080. So let's just try to hit this endpoint. So let's just bring Postman here. Okay. And let's just say localhost 8080 users dash slash Avilas to enter. And let's say it's just giving me the response user created Avilas. Let's say if I'm going to take another user, yeah, it's just giving me the right output, and the status code is also fine. So our demo endpoint is right now ready. So imagine this is my user service. Okay, so the job of the user service is going to create a user, persist it to the database, and return the respective user information. That's what we are doing right over here. The next thing that I'm going to do over here, I'm going to create another Spring Boot project. And this is going to be a Spring Startup project. And this is going to be my next microservice. And this one, I'm going to say email notification service. Okay, I'm going to do next. And I'm going to use the same Spring Boot DevTools and Spring Web over here. And I'm going to do the finish. Well, did I change the, oh, sorry, the package name I haven't changed. So let's just rename this. So I'm going to say refactor, rename, and change the package name as email service or email notification service. Okay. And I'm going to do OK. And I'm going to do OK. All right. All good. So my email notification service is here. Now let me close this user service and let's just stop this application. Okay. Let's just focus on the next thing. So right over here, again, I'm going to create a new class. And this is going to be my notification controller. All right. And here I'm going to put it inside a controllers package. All right. I'm going to do finish and let's just expand this. So right now I'm going to mark this as REST controller. And right over here, I'm going to create a new method right now. And this method is going to help me to send email to a particular user. Okay. I will create a method called send emails. Okay. I'm going to have a method like this. It just says send email. That will sound better. And let's just annotate this method with get mapping. For now, you can make it a post call, but I'm going to make it get for now. And let's say send email just for simplicity. And obviously to whom you want to send the email, just give me the name. Okay, I'm going to say user name, something like this. And this will be dynamic. And when somebody will hit this endpoint, he will give the username to whom the email will be sent. So let's just capture this username over here. Again, I'm going to use path variable. And the next thing I'm going to do over here, I'm going to write the email sending logic here. Okay, we're going to be focusing on this later. And I'm going to just to return a text, let's say email sent to the user. And I'm going to add the username over here. There you go. So I'm going to change the return type as string. And this looks all good to me right now. Okay, let's just test this application right now. Notification controller, whether the send email method is executing fine. So to check this, I'm going to make sure this email notification service is up. So I'm going to start this and let's just test this endpoint. So first of all, by default, it is starting in 8080 port number. So let's just do one thing. Let's just stop this because by default, it will start with 8080 port number. Let's just change the port. So I'm going to go to source main resources and the application.properties. And here, let's just have a server.port. And I'm going to change this to 1990, let's just say. Okay. So I'm going to close this. I'm going to close this as well. And I'm going to start the email notification service right now. Okay. So right now, I think the service will up and running with port number 1990. So let's just test this out right now in another tab. So I'm going to copy this. And I'll go over here. I'll paste this. This will be send email. Okay. And let's say you're going to give the username. Okay. So let's say the username is Avilash. Okay. Or maybe I can just say avilash@gmail.com. Okay. So this port number I need to change to 1990. And let's just do send. Yeah. The email sent to avilash@gmail.com. So imagine everything is good and you haven't written the logic, by the way, the email sending logic. So that's a different part of the thing and we will write the logic. That's not a big deal. Okay. But imagine we have this endpoint right now and which will help you to send email to a specific user. Now you have an email notification service and you have a user service. You have two different microservices. And let's say if I'm going to start this service, this is going to up and running in port number 8080. This is up and running in port number 9090. And if you're going to see over here, 9090 port number send email. Let's say this thing is working good. And let's say port number 8080 user. And let's say the username over here is sahil@gmail.com. Let's say this is the user that I want to create. Imagine this is my username. This is the email ID is my username. Just think like that. Okay. So yeah, so user created and this is the user. Okay. So my 8080 port number application user service is working good. And my 9090 port number where my email notification service has been deployed, that is also working good. But right now the flow should be this. Whenever we are creating an user give me the data. Let's say when the user will hit this endpoint. The thing is, we should create the user, save it to the database, and then we need to make sure a welcome email has been sent to this email ID. Okay, so that should be the complete flow. So right now, to follow the best microservices architecture, the user service just create the user. The email notification service just send emails. But right now, the user service needs to talk to the email service in order to send a welcome email to an user after the user registration is done. Okay, so let's just try to do that thing. Let's just do some microservices communication. So this user service can talk to the email notification service. So after the user registration is done, we can call to this microservice so that it can help us to send the email notification to a specific user. Okay, let's just get started with that right now. Okay, so right now let's just go ahead. Let's just do a REST call from our user service to the email notification service. Okay, so I'll go to the controller. There we go. That's my controller. Let's just open this up. And inside this controller, imagine this is my create user method. So whenever I will accept the username, so I will persist the username to my database. And then here, I need to make sure I need to send an welcome email to the user after the registration is done. So here, I will write the send email logic. All right. So let's just write that. So, well, this microservices job is, just to create the user. How the email will be sent, that responsibility has been taken by our, email notification service. So we don't need to write the logic over here. We just need to call to that microservice and give the responsibility of email creation or the email sending to that microservice. Okay. So how to call that microservice? Okay. So here we have the endpoint. This is the endpoint we need to call. So let's just come to our user controller. This is the endpoint we need to call. But how to call this endpoint? Okay. So to call this endpoint, we need to make a REST call. And for that, we need a REST template. Maybe any kind of REST client you want in order to make a call to that particular microservice. You can have REST client. You can have any HTTP client or web client or FIN client, whatever you are learning. But right now, I will go with REST template. So I'm going to say REST template over here. REST template is equal to new REST template. So I will just go with simple REST template creation. So right now, let's just take the REST template. So here I'm going to use the REST template right now, and I'm going to make a call. So REST template dot, and I'm going to make a call. I'm going to make a call to what? To this endpoint, right? So I'm going to copy this, Control X, and I'm going to say, this is going to be a get call, post call, delete call, or what call. So here in the post main, we're making a get call, right? So we are making a get call to this endpoint. So let's just come back and I'm going to say dot get. Let's just go with get for object. Okay. So here I'm going to be hitting this endpoint. Okay. So http:// localhost 9090 send email, and this will be your username. So this will be dynamic. Whatever the username the user will pass, this will be replaced with this one. So we'll fix this. But if you're going to hit this endpoint, what kind of data that I'll get over here? So if you're going to see our Postman, whenever you hit this endpoint, it is just giving a status that email sent to the user this. So whenever you hit to this, it's going to give you this data, and this is string data, right? So right now, so whenever I'm going to hit this endpoint, I'm going to get what kind of data? String data. So I'm going to say string.class, and there we go. That's the response that I'm going to get over here. And if I'm going to do control1 assign statement to a new local variable, it's going to give me the string data back. So this is going to give me the response back. Okay. So I'm going to say user created, and then I'm going to paste the username. And before the user gets created, we're making another REST call over here in order to make sure, we are sending an email to the respective user. But this username has been hard coded over here. What if somebody will send the username as, let's say, rahul@gmail.com? Then we need to replace that with this guy, right? So this will be dynamic. So I'm gonna make this dynamic. Let's just say username, something like this. This will be a dynamic thing. And the data for this, we're gonna give maybe over here. So how to give the data? I'm gonna create a map over here. Let's say map, and I'm gonna give the key and value. So the key will be string, okay? Because this is the key, okay, username. And the value will be also a string. Let's say string. Let's say user details, okay, is equal to new hash map user details, and this is a map, so I can just do put. Okay, so the key value, let's say the key is going to be this username. Okay, this is going to be the key. Okay, the value is whatever I'm capturing, and let's say the value I'll capture over here. Okay, so I'll copy this and I'll put it over here. This is going to be the value. Okay, so this is my user details right now. I can copy and I can put it over here as a third parameter of my get for object method. So I hope that you can see it all in one screen. So this is my REST template and get for object method. I'm making a call to this URL, and this is the response that I'll get, that I'll be capturing after this is going to return. And this data will be read from this user details, because this is where I'm going to put the things. So here I'm making a REST call to make sure we are sending an email to the user after the user has been persisted to our DP. Let's just see whether that works right now. So let's just see whether both of our microservices are running. Okay. So right now I'm going to go ahead and I'm going to go to my localhost 8080, which is my user service. And I'm going to give the username, let's say sahil@gmail.com. So I'm going to do send. Okay. And before I'm going to do anything, let's just come to our user service. Let's just activate some logger over here. Let's say once we invoke this REST call, whatever result this endpoint is giving us, let's just try to print it. Print the response that I'm going to get over here on my console. Okay. Now I'm going to save this. I will go over here and I'm going to hit this endpoint. Okay, and it's just saying user created sahil@gmail.com. So let's just go over here. Let's just check the console, and this console is for my user service, and you can see email sent to user sahil@gmail.com. So right now that means we are hitting this endpoint, and this endpoint is right now giving me this response. Okay, so internally, if you're gonna go to our other console, our other application is also running right over here. This is my email notification service. If you're going to go over here, your email notification service, notification controller, internally, this has been called, right? And this is what it is returning. Okay. So if you want to activate any logger over here, you can also do that. Email sent. Let's just fire another request. Let's just clean up everything. Let's just clean up this log, and let's just clean up this log. You can switch to both of the log from here. Okay, if you're using STS. So right now, let's say we are on the user service. So I will go again, and let's just try to create a user called abi@gmail.com. And it's just saying user created abi@gmail.com. If you're going to see over here inside the user service log here, It is just saying email sent to the user of gmail.com. So that means this user controller inside this method is getting fired, and this response that we're getting over here, that we are printing over here, and this is the line. Okay, and if we're going to switch back to the email notification service, you can see a log over here called email sent, because it's received a kind of request to this microservice, and right now both of these microservices are communicating. From here we're making a call to here. All right, now comes the fun part. Now I have few questions for you. First of all, tell me right now, we have a couple of microservices, the user service and the email notification service. Both are independently deployable. This has been deployed inside a Tomcat server, and this has been deployed inside another Tomcat server. The two services running in different servers, so they are independently deployable. Okay, so we are kind of following a microservices architecture over here. Now my question here is how these two microservices are communicating. Well, the couple of microservices are communicating through REST, through a REST call, but that is a bad approach with respect to this scenario. Why? I'm going to be coming into all the point step by step. The first point, now I can see all of our microservices are up and running. This is up and running in port number 8080. This is up and running in port number 9090 inside a Tomcat server. Everything is good so far. What if the email notification service is down right now? What will happen? You will say, Abhilash, it's very simple. If it is going to down, whenever you're going to be hitting the 9090 endpoint for the send email method, this will not work. Okay, this will not be able to connect because the service is down, and that's obvious. But that's not the only problem. Now the problem here, if you're going to go to this service, okay, the user service, and if you want to create an user here, and if you're going to do send, well, looks like this is also down. This is also giving me a 500 status code. That means there is some server error is happening whenever I'm making a post call and trying to create the user. And that's bad. Because of this microservice is down over here, this microservice is also down. And this is kind of a failure. It's kind of a chain failures. Why? Because see, the problem here is that this service internally calls this service. You know how that works, right? User service. If you want to go to the controller, user controller, and it looks good, right? This is the endpoint we are calling, but internally it is making a REST call. Now the problem is, now this endpoint is right now not available because the server where this email service has been deployed, this is unavailable, this is down. Now because that is down, this create user method is right now throwing error while creating the user, and that's a bad thing. Because if the email notification service is not able to send an email, a welcome email after the user registration, then we should not consider this transaction as failure, isn't it? Because the sole responsibility of the user service is to create user. And right now, this service is up and running. You can see this service is up and running. That means we can collect the data, we can save the data, and that's it. That's the responsibility of this service. But as we are sending the email, right, and we are making a REST call to the other service, as that service is down, this service right now also giving us a failure message whenever we are hitting this endpoint, and this is bad. Imagine in your website, a user is trying to register, and if he is going to see this kind of error message, he'll simply go away. And if you're losing a user in your website, you're simply losing business. Not only this, even if you see, let's say we're going to start the email notification service. Now the things will back on track, so things will work fine. But I'm going to showcase you another problem. If you're going to go to your email notification service, imagine if this email notification service is a little bit slow. Okay. And to simulate that, what I'm going to do, I'm going to go to the controllers and I'm going to open up the controller right over here. And I'm going to expand this. And imagine here, I want to simulate a slow server response kind of thing. So this is the response we're giving whenever somebody is hitting this one. Imagine I'm knowingly creating a delay over here. Let's just say thread.sleep. And let's just wait for 5,000 millisecond, which is 5 seconds. And this is going to throw us some error. Let's just handle it over here inside the method itself. Okay, let's just save it. Let's just redeploy the changes and just see the problem right now. Okay, now I'll go to the user service, trying to create the user, and let's just do a send and see it keeps waiting. It keeps waiting. And after 5 seconds, you can see it took 5 seconds right now to make sure the user has been created. Now the user service is up and running fine. And there is no problem over here. But the problem here is that this call is taking 5 seconds. This 8080 port number user service is running fine. This is healthy. But this is our culprit service, which is taking a bit of time to produce the data. But if this is slow right now, this service is automatically becoming slow because internally over here inside our user controller, we are making this REST call. That means here it is a blocking call. That means right now we are receiving the request, let's say saving the data, but whenever we are making this REST call, here our application stuck. Here we are not getting the response quickly. It is taking 5 seconds. That means it is creating the delay. This endpoint only creating the delay. But because of this is causing the delay, our user who is hitting this user service endpoint, he is also experiencing a delay. Now, that's a kind of horrible problem, right? One slow service can cause slowness in the other services as well. And this is a very bad thing if you're using a RESTful approach over here in order to make the microservices communication. Let's say tomorrow I will have a new requirement, or my company will have a new requirement that after the user registration, you also need to send a SMS notification to the user. Then what you will do, you will go ahead, you will create a new Spring Boot project over here called SMS notification service. Okay. And then you will write your logic how to send the SMS to the user. But the problem is once you complete writing that microservice, again, here you are writing send email logic. Here, again, you will write send SMS logic. Here you'll just make the REST call. So I can just say send SMS call external service. Okay. And this is going to be a REST call. Let's say REST call to external service. Okay. And just like that is send email. And here also you are calling external service, right? So you are making a REST call over here. Maybe tomorrow you want to send SMS to your user, you have new business requirement, then again you have to have another microservice call over here using the REST, okay? And then the more new requirements that you're gonna get, you're gonna be keep feeding in the new URLs and new REST calls over here, and the more REST calls that you're gonna be having over here inside the create user, it will be more prone to failure. Because what if the email notification service right now comes back, is serving us the request in a pretty good speed. But what about this service is down? Okay, then again, that is another headache, right? And another important thing is that whenever you are creating all these microservices, you need to make sure that these services are loosely coupled. Why you are creating all these services? You are creating all these services because they should be independently deployable. The user service, the team who is working with user service, they should not hour about what is happening inside the email service. But let's say if the email notification service whoever is handling this microservice, let's say there is another team in your company who is handling this microservice. That team right now decided that, okay, we will right now change this endpoint. Let's say the email notification team want to modify this URL to email/username. Then what will happen? Then, your user service also will not work right now. See, if you're going to hit this user service endpoint, you're going to have a problem. This is causing an error because right now this URL is complaining. And because this resource, you can see no static resource, send email, this is available. Right now, the email notification team has changed their API without letting the people know who are working on the user service. And that is a serious problem. Now the people who is supporting this service, they need to come over here and they need to change this endpoint over here and make this email. And then only the things will work. Okay. So if you're going to come over here and do a send, now I think it is back on work, and the email service right now is just taking a bit of time and helping you to create the user over here. Now the problem here is that these two microservices right now has been developed by different teams. Okay, let's say this service is maintained by a different team. This service is maintained by the different team. Now both of these teams right now need to communicate, right? That, okay, we are making some changes, so you replicate over here. We don't need to do that because microservices need to be handled separately by separate team. And any changes over here should not force us to make changes over here. Because if you're going to change anything over here, again, we have to create a new build and we have to again deploy it inside our server and start our server. Then only the things will work. In our case, we are in the local server, so we are just hitting a button to start and stop the server. But in production, it is going to be a tedious job to restart the server or to redeploy the changes. So it's not good if something is getting changed over here, we should not change it over here. And that's what we call the tight coupling. Right now, our user service, the create user method, is tightly coupled with this service, which is the email service. This is the endpoint. This is the REST endpoint. That's why we can say we have a tight coupling over here. The user service is tightly coupled with the email service. Let's say they will come with a new spec. Okay, you need to right now have a SMS notification service. Again, if you're going to make REST call over here to the SMS notification service, then again, your user service will be right now tightly coupled with the email notification service and SMS notification service. And that is again a problem. Okay, so you need to make sure your services are not tightly coupled with each other. All right, so right now things are getting intense over here and we're finding a lot of problem. And trust me, all these problems are pretty much solvable. So that's why we have a separate module called Spring Cloud. And we have lots and lots microservices design pattern to solve this kind of problem. But right now we'll try to figure out the root cause of our problem and then we'll try to resolve it. By the way, you can hear out a heavy rainfall noise outside. If that's coming into my microphone, then I'm sorry about it. I can't do anything. It's basically around 10:30 p.m. and it's rainy season here in India. If you are watching this video from India, then happy monsoon. Hopefully you are enjoying it. But in our area, it's like a lot of rainfall is right now happening. So it's pretty difficult to go outside even. So yeah, so just excuse me for the rainfall noise if you're getting anything over here. Well, by the way, from which city you are from? Well, you must be working in Bangalore or Hyderabad or Pune or Kolkata or Bhubaneswar. But which city you are from, your origin city? Can you just let me know in the comments so that I can know my subscribers are from this city? Okay, just mention your city name in the comments. Okay, coming back to this. Okay, let's just try to find the root cause right over here. And it's very, very simple. All these problems are happening because of this internal REST call in our user controller, which exists inside the user service right over here. Okay. That's why the problems are happening. One thing you have to notice over here, whenever we're creating the user, the role and responsibility of create user should be just persisting the user detail inside our DB, and that's it. Why the user need to call the email notification service for a welcome email? And if it is doing even, if the email service is not able to send the welcome email to the user for any reason, if it is down, then we should not take the entire microservices down. We should not stop the user to register inside our site. But as we are getting an error over here, the entire flow is throwing exception and we're running into issues. Okay. And this pattern is synchronous right now. You see, somebody hit this endpoint. Okay. All the lines over here will be executed line by line, line by line. But when this line executes, it is waiting from the response from the other service. Once we get the response, let's say we're getting the response after 5 seconds, 10 seconds, then only we'll be able to go to the next line. If something happens wrong over here, then we'll never come to this line and we'll never be able to return the user a message that your user ID has been registered. Right now, you can use this user ID to log back into our site. Okay, that's the problem. Here, this is a synchronous call that we are making over here, and that is the problem. And here in this case, the user service and the email service communication should not be synchronous. There is no need to make the synchronous call, and we should not wait over here after making this call to make sure the email has been sent and proceed to the next line. That should not happen over here. If it is a payment service, then different thing. Let's say a user is signing up and you are running a membership website, and right after the user registration, before you make sure the user will end up in your DB, if you want to make a call to a payment service and you want to accept some payment from the user, and then you should have wait for the response. That makes sense. In that case, a REST call should be fine. So after the user registration, you make a call to the payment service, wait for the response from the payment service that the payment has been made. Then you are processing the user and making sure the entire transaction is marked as complete. That makes sense. That time the REST call should be fine. But here in this case, the user service and email service, I don't see any reason why we need to wait till the registration email has been fired to the user and a response has been coming back to us saying that the user right now received an email, then you proceed further with the entire flow. Here we have a scope to make the thing a little bit of asynchronous. Okay, so how to do that? And for the asynchronous communication between the user service and the notification service, we can bring in some message broker like Kafka. Okay, so that these two services can communicate with events. Right now, these two services are communicating through REST call, and REST call is kind of blocking the thing. Okay, so right now we can go asynchronous. Let's say the user service responsibility is to create the user. Once the user has been created, it is just going to send an event and put it inside a message broker. Let's say in a Kafka broker that, okay, a user has been registered right now, and here is the data. And right now, the consumer service like email notification service will be notified that, okay, right now in the Kafka server, we have a new user registration event. So from there, we can pick off the data and the email notification service can grab the data and can send the email to the respective user. So we do not want direct communication between these two services. We can have a kind of broker in between these two microservices. And these two microservices will right now communicate through the broker, through the event. Okay, they will communicate through messages. And this is exactly how the things will be done. And let's just try to implement that right now in our application. All right, so right now we are all set to bring in a message broker, maybe any message broker like Kafka, RabbitMQ, ActiveMQ, Apache Artemis. There are a lot of different types of message broker, but we're going to be using one. If you understand one, the concept remains same. everywhere. So you don't have to worry much. So right now, let's just bring in a message broker, and we're going to be using Kafka right now. So right now, let's just bring in our terminal window and let's start our Kafka server. Don't worry much. Don't think much. If you're very new to Kafka, then I have a separate playlist for Kafka Foundation and Fundamental where you'll learn everything about Kafka. Even if you don't know much about Kafka, still you can follow along because you can understand how different components of Kafka works and what is the purpose of using Kafka over here for our microservices communication. And then you can dig deeper and can start learning more and more about Kafka. But right now, let's just bring in Kafka, just like you are starting your Tomcat server, which is a web server, just like we're going to be bringing in the Kafka server, which is a message broker. So right now, let's just execute this command, which is our Kafka server stat command. Using this command, you can start your Kafka server. And obviously, whenever you are starting your Kafka server, you need to have a configuration file. And here in this configuration file, we have written all sort of configuration that is needed to start the server. Don't worry much how to write this file because whenever you'll download Kafka, you'll get it for free. And this is available inside this folder. So you don't have to worry much about this right now. So let's just hit enter and let's just start the Kafka server. And now the Kafka server has been started, as you can see, and it is running. But in which port number it is running right now? Let's just do Control F and let's hit 9092 because I know that's the port where the Kafka server is running. So if you're going to say here, the listener's port, it is pointing to the 9092 port number. Just like your Spring Boot servers are running on Tomcat server on the port number 8080 and 9090, like that 9092 port number where your Kafka broker is running. This is very important to know where the Kafka broker is running because let's say if you are going to your user service and over here, your requirement is inside your user service. If you're going to look over here, you don't need to do any REST calls over here. Okay. So what you need over here, whenever you're creating the user, okay, you are capturing the details of the user over here. But right now we're just capturing the username, but whatever it is, we need to store the user details in our DB. And that's the code goes over there. There will be a DB call which will save the data to the database. That's none of our business right now. But after everything is done here, without making any REST call to the email notification service right now, without having direct communication with the email notification service, here, I just want to send a message to Kafka broker, okay? And if I want to send a message that, okay, now this is the user, let's say, this name we are capturing as avilas@gmail.com. Then we're going to give that name to the Kafka broker and tell Kafka broker that, okay, here is the event which happened in our system right now. Somebody is trying to doing the user registration. And this is what we have captured the details about the user and we are sending it to the broker. So you keep it. Now, this is a Spring Boot application. So this Spring Boot application will communicate with the Kafka broker. And to do that, this application need to know where the Kafka broker is running, right? And that's what I'm trying to show you over here. It is running on port number 9092, and there's the listener port. Okay, just look over here with this port number. Now the next thing, well, we need to send a message to the Kafka broker. So whenever somebody registers, that's actually an event which is happening inside your server. So we need to capture that event, or we need to capture that message, or we need to capture that data, whatever the way you want to understand, that's fine. Once we capture that, we need to send the message to the Kafka broker. But when we will send, let's say we're going to say, hey, Kafka broker, which is running a 9092 port number, here is the name that we are capturing. Let's say, here is the name, or here is the username that we are capturing, okay? So we will give you this. But where this server will keep that information? Well, we need to have some kind of storage folder, right? Something like a database table or something like a file or folder system where we can actually store our data. In Kafka, the way we store the data and the place where we store the data, that's called topic, okay? So we need to create a topic right now here inside the Kafka broker, and a debug guy will create a topic for you and we'll give it to you that, okay, hey developer, take this topic. This is just like your database table. You're going to be storing the data for the new registered user over here inside this topic. Okay, so right now we don't have any debug guy over here. We are the developer, we are the debug guy. So let's just go ahead and create the topic. Okay, so in this window, the Kafka broker is running. So I'm going to create a new terminal window right over here, new window. And right over here, let's just try to create a topic, which is going to be a storage place for a newly registered user. So here I'm going to create a topic. So to create a topic, I'm going to use a Kafka topics.sh command. And I'm going to say, okay, I want to create a topic. So I'm going to write a create command. And I want to create what? I want to create a topic, and I want to create a topic called, what is the name of the topic? Let's say the name of the topic is going to be user events, okay? Because, or user registered event. User events is fine. New user events or something, okay? Maybe I'm going to say new user event. So that's the topic name or the folder name where our new registered user data will go. And this is the data that our producer application, which is the user controller, this is the application which is going to generate data and going to send it to our Kafka broker. So we can treat this application called user service as a producer service that's going to push data to this topic called new user events. All this topic we will create inside the Kafka server, which is running on the port number 1992. So to connect to the Kafka server where we want to create the topic, we might have 2 or 3 or 4 Kafka server running in our machine. We want to connect to the specific one, which is running on localhost 1992. So to connect to that, I'm going to use this command called bootstrap server, and I'm going to connect to the server, which is running on my local host, and the port number is 1992. And I'm going to hit enter right now. Let's just see whether the topic is getting created. It is saying it is not able to recognize the bootstrap server because the spelling is incorrect. So let's just find out the same command one more time. And this is bootstrap server. Okay, let's just hit enter one more time. Now the topic has been created. This is the folder where we're going to be storing our data. Let's just see whether the topic exists or not. So using the Kafka topic command one more time, right over here, we can do -- list to find out what are the topic are available in our Kafka broker right now. And which broker we'll connect to? We'll connect to this broker, and we'll check what topics are available inside this broker. Okay, so let's just do enter, and we can see we have a topic created. Right now we can give this topic to our Spring Boot developer, and we're going to say, okay, whenever you're going to send a message to the Kafka broker, let's say this is the message that you want to send, you can use this topic. This is the topic, or this is the storage place where you need to push your data. And that's fantastic right now, right? So now everything is ready. Now this application user service, once it creates an user, we can persist the user on the database, and we just need to make sure we don't need to do any REST call. We just need to place the same user information inside the Kafka broker. We need to send the message or this username to the Kafka broker. And how we can send it? To send it, we need some kind of method call. We need to have some kind of method so that we can use the send method or something, right? So where is that send method? Well, for that, we need to use a class called KafkaTemplate. Just like you have JDBC template, just like you have REST template, okay? Just like that, you have Kafka template to do Kafka related operations. So I can bring in the Kafka template right now. Can I do control space and look for Kafka template? Well, I am not finding any Kafka template over here. So how to bring in Kafka template? Well, for that, I need to have a new dependency inside this user service. So I'm going to click on Spring Add Starter, and I want to bring in Kafka for my Spring Boot application. And for that, I can look for Kafka Spring for Apache Kafka. There you go. You can just update your POM file, and you can just do finish. Okay, now you can open up your POM file, and there you go. That's your Kafka dependency, right? So right now I can just do one thing. I'll just do a little bit of refresh here. So Mabin update project just to make sure we're aligned with our dependencies. And right now, can we do a control space? And there you go. We got the Kafka template. We can use this right now in order to send messages to the Kafka broker. Okay, so we can just do Kafka template, and right now this Kafka template, using this, we can just do send. Well, we're not getting the send method over here because we haven't filled off this key and value. But if I'm going to simply do this right now, if I'm going to do send, you can see I have the send method where I can send a message. Okay, so I can just do send and I can use this message right over here. Okay, let's say this is the message that I want to send. Okay, let's say this is the message that I want to send. So this is how we'll be able to send the message, right? This is what we want to do. But here we need to analyze this a little bit more. We're almost done. Well, if we want to send this message, this is what? This is a string type, right? So if you want to see the Kafka template here, it gives you two things. You need to specify the key and value whenever you're creating the Kafka template. Now, whenever you're going to send messages like this, the messages will be something like this. This is the value of your message, okay? And then with each message, there can be a key attached to the message. That's optional. You can send the key or not. For an example, for this, you can assign an ID for this message. Here in this case, the key is an integer and this is the value, which is a string. If you want, you can write the key as string as well. For an example, you can just write user name and you can just send this message. Okay, so this is the key, this is the value, but the key is optional. So in our case, we will not use key, and this is the value that we will directly send to the Kafka broker. But whenever you are sending messages like this, you need to specify the type of the key and the value over here. Right now, the key type will be string. Okay. Anyhow, we will ignore the key for now. We will not use the key, but the value is most important for us right now. And value is also going to be string type because this is what is going to be our value. Okay. The Kafka template .send method we're going to use. And if you see the send method, there are different types of send method over here. So one of the send method, you can see one of the send method, it takes 3 parameter, which takes a key, takes the value, which is data, and it needs to know the topic where actually you need to send the data. Okay. Let's say in our case, we need to send the data to new user events topic. Okay. That's going to be the parameter. But in our case, we don't want to use key. Okay. We only want to send value to a specific topic. So do we have anything available like that? Yes. Looks like string topic, string data. Okay. We can use this one. We can give the topic name. We will say, okay, to this topic, I want to send data. And this is the topic that we have just created over here. And the value that you want to send right now, which is going to be this. Okay. And this we will get from here. This is the thing. This is the user data that we are capturing right now. So we can put it over here. There we go. And we can remove this right now. I think we are done. Yeah, we are done, right? So do a command shift O, control S. Okay, let's just start the user service right now. Okay, and looks like our user service has been started. Perfect. So right now, as our user service is up and running, let's just try to fire an endpoint over here with our postman. Let's just try to send a user called anil@gmail.com by hitting our 8080 port number user service. Okay. And we get a internal server error and we get a null pointer exception because of the Kafka template. And that makes sense because we have a problem, null pointer exception, because the send method we are using over this.Kafka template, which is null. And obviously we are using the send method over the Kafka template, and the Kafka template object we haven't initialized. So the default value for this is null. So right now, I don't want to create the object for this Kafka template because I have Kafka related dependency inside my Spring Boot, and as I know Spring Boot has the auto configuration feature, it is going to create the object for KafkaTemplate. So I just want to use the object of KafkaTemplate that the Spring Boot is creating internally, and I don't want to create the KafkaTemplate object by myself. And in order to do that, you know how to do that. You can just use a auto word over here. Okay, so right now, whatever object Spring Boot is creating behind the scene for KafkaTemplate, that will be injected to this particular variable, and now we can invoke the send method on top of it, and there will not be any null pointer exception. So let's just run this one more time, and I think it will be automatically refreshed. Yeah, it's automatically refreshed. So let's just go to our Postman right now one more time, and there you go. User created anil@gmail.com. And let's just analyze our server console a little bit, and there are a lot of things over here. And all these things right now belongs to Kafka. So right now I feel the Kafka is pushing the message, is connecting to the server, and is pushing the message to the Kafka broker, which is running over here. So if you're gonna see in this terminal, we are running the Kafka broker, right? And I think to here, the message has been pushed. You know, you can see the initializing the Kafka metrics controller. There is some producer client ID is instantiated. There is a lot of things going on behind the scene. Let's not worry about it right now. There is a commit ID. Looks like our message has been committed to the Kafka server. Well, if you have a question like, well, Avilas, we haven't specified for this Spring Boot application, we haven't specified anything right over here inside the application.properties file. So how our Spring Boot application is connected to the Kafka server right now? And that's very simple. The way it is connected to the Kafka server because of the default configuration. And there are some default configuration comes with the Kafka dependency, which actually pushed the data to the Kafka server running on 1992 port number, because the Spring Boot know if the Kafka server running on the default port number 1992, then without any modification over here in the application.properties file, without specifying the details about the Kafka server on the application.properties file, we'll still be able to push the data where the Kafka server is running, because that's the default port Spring Boot knows where the Kafka server runs. And that's why I feel the message went through, but how can we test that? The message is actually there with the Kafka server right now. Well, so to test this is the topic that we have. So let's just test whether the message actually arrives in this particular topic. And to check this, we can create a consumer, okay? We can create a Kafka console consumer over here. And I'm gonna say Kafka console consumer.sh. When we're going to be consuming the value from the Kafka topic, okay? So our producer, our Spring Boot application being the producer, pushed the data to this topic. Now from this topic, we want to consume the data. So this is our Kafka console consumer, and we're going to say, okay, right now we're going to consume the data from the topic name this. And we want to consume data by connecting with the Bootstrap server, which is running on localhost 1992. That's the Kafka server we are trying to connect. And we want to read all the data that we have inside this particular topic from the beginning. Because by now we have, let's say I'm pushing this 3, 4, 5, 6, 10 times. So more and more user, let's say I'm pushing it over here, okay? So using the producer right now, there are a lot of things I have already pushed through the Kafka broker. Okay, a lot of messages are already there inside the Kafka broker. So right now, this consumer is going to read all the messages right from the beginning. And to do that, I want to give one more command called from beginning over here. And let's just see whether we got all the messages right now. There you go. So we get all these users which has been created. The consumer application is giving us all the data, right? And we are consuming all the data from this new user events topic. And by the way, your producer application, which is Spring Boot, is sending the messages to that topic. Right now, let's just see these things live. Create another user, let's say Abhipsa, okay? And you can see Abhipsa goes over here. Okay, let's say Sahil. Okay, so Sahil goes over here, so all working good. But right now, this consumer application we have just created for tasting, okay? In reality, we are not doing anything by consuming this thing. But in real time, if I'm going to do Control C and I'm going to stop this consumer, I don't need this consumer anymore. So what I want in reality, this email notification service is going to be a consumer in reality, okay? Because we actually want to consume the user which has been created, which has been pushed by the publisher to the Kafka broker. And using this email notification service, we're going to consume the data, and then we want to send a real email to the user. And to do that, I'll go to the source main Java, first of all, and here I will make this application a consumer, a Kafka consumer, which is going to consume the value from the Kafka broker. And to do that, I am going to go to my controller, first of all. Here I have written some data. Let me close this. And here I really don't need to write a REST controller right now. So I'll take the superpower from this notification controller by commenting all these things. So right now, this will not behave as a controller because we have commented this out. Let's just close this. Maybe I'll go to the starter application right over here. And here, I will just develop a method called public, let's say void send email. That is a method, let's say. And this method work is to send an email to the user once it is created, okay? But from where we'll get the new user events data, okay? And for that, this method need to connect to the topic, which is new user events, and need to gather data from that particular topic. So this method here, I want to listen to all the events which are happening inside that particular topic where our producer is giving all the, new user events that it is firing over there. I want to listen to each events that the producer is firing. So right now what I'm going to do here, I will, first of all, to make this a consumer, I need to use an annotation, and that's called Kafka listener. But I will not get that annotation because this Spring Boot application also need to have the Kafka dependency. So let's just add it first. So I'm going to say Spring for Apache Kafka. I'm going to be adding this. Okay. I'm going to use pom.xml just to finish. Okay. I'm going to refresh this. So now I've been update project. There you go. And right now over here, I can use Kafka listener. Okay. And there you go. So right now I want to listen to the topic. Okay. And the topic name is, let's say, topics. And what is the name of the topic that I want to listen to? Let's say I want to listen to this topic. This is my topic where the producer is pushing the data to. Remember, this is the topic that we have created. Okay. So let's just keep the topic name here. And there we go. Now from this topic, I want to fetch the data. Well, in this topic, what kind of data is arriving? Well, the data which is arriving in this topic are in string form. So what I'm going to do, I'm going to write string username. Okay, so I know I'm going to get username, and those usernames are in string format. So the username will be fetched from this topic. Whenever there will be new events will happen on the Kafka broker, that event will be fetched and will be binded over here, and the type of that is going to be string. And now I'm going to send the email using this username. Okay, so you can write the email sending logic here and send the email to this username. Okay, so that you can do. We can do that later if you'll be interested later. Let me know in the comments if you want more information about the Kafka and the way it works. Maybe I can create more videos. Put that in the comment. But for now, I just want to do sysout. And I'm going to say sending email to, and let's say I'm going to concatenate this username over here. Okay. And maybe this is coming from our email notification service. So in my log also, I'm going to say email notification service. Okay. Sending email to the username. Okay. And I think my application is ready right now. So I can just do one thing. I can start my email notification service as well. No, okay. We are getting a illegal state exception. No group ID found in consumer config. Okay. So in the Kafka listener, it is asking for a group ID is required whenever the group management is used. Well, we'll talk about the consumer groups and all that in the Kafka Foundation course. You can go and check it over there. But just one tweak we need to do. So everything is set. Only here you need to specify a group ID. And this is what we call a consumer group ID. Like if you have many consumers consuming the messages from the Kafka broker. So if you have 1, 2, 3, 4 different consumers, then they all can consume messages as a consumer group. That's a different thing. Forget about it. So just give the group ID. Let's say I'm going to say email service. Okay. So this is the group ID I'm going to give over here. We will talk about the group ID later in the course. Okay. So ignore it for now. So can we start it right now one more time? Yeah, there you go. We have, yes, we have started our Kafka server. Everything is up and running. So right now, let's just see what is going to happen, right? So I think here we have the email notification service console. And if I can go back, the user service is also running right now. Pretty much fine, okay? So right now, let's just try to do this. I will go to the Postman, okay? I don't need this console anymore, so I can just minimize this. Let's say I'm gonna fire a new user. Let's say that's supriya@gmail.com. If I'm gonna do send, yeah, user has been created, so our user service is working fine. So I can see right now in the notification service console right over here, it is sending the email to supriya@gmail.com. So right now, you can see the other console, the user service console. You can see right now over here, after the user has been created, right over here, user controller, after the user has been created over here, is persisted to the DB and then sent the user event to the Kafka broker. And it sent the user event to the new user event topic. Okay, so whenever a new registration is happening, that's an event which is occurring inside the server. You are just capturing that event and sending it to the Kafka broker, and you are rest assured that whoever want to consume that, this is their part of the job, they will be consuming it. And here there is no direct coupling. We don't have any REST services or no REST URLs, no direct coupling, no tight coupling, with another microservice. So our job is just to save the data and then send the event to the Kafka server and returning the user the data. And right now, the other service which is running, which is our email notification service, that is right now consuming that event. This is the user which has been created. Now fetching the user detail and sending the email to the specific user. And that's the job of this Kafka listener that we have created. You can treat this particular application as a consumer application. So the producer is producing the data to the broker and the consumer is consuming the data from the broker. And this is as simple as that. Well, so everything over here is running with a default Spring Boot configuration. We haven't configured much over here. And this is a very simple example. We can leverage this more and more in order to give you more and more ideas. So as I said, if you are interested, you can just let me know in the comments so that I can create more Kafka videos or the follow-up videos for this particular series. But for now, it is going to be a standalone videos. Okay, based on your interest, I can create the videos. So let me know in the comments if you're watching this video and like this video and let me know your thoughts about it. What if the email notification service is down? Okay. I'm stopping the email notification service and this is stopped right now. It is not running, it's terminated, right? The email notification service. So right now, if you're gonna see, only our user service is up, but the email notification service is down. But don't worry, there is no direct communication is happening from here to here. So what about, if you're gonna send a new event, let's say abhilash@gmail.com, enter. See, we got a 201 response and the user is created. There is no failure. There is no error message over here. And look at that, it is still up and running and there is no issues. Right now the email service is down, but it is not bothering the user service. And whenever this wakes up, you can see right now it is sending an email to avilas@gmail.com because right now it is fetching the data from the broker. And then the broker is saying, okay, when you are down, there is a new user has been registered. Now it can go ahead and send the email. And even if here, if you're going to have a lag, let's say this is sending email in a little bit late. So let's say if you have a thread dot sleep over here, and if you're sleeping for, let's say 5,000 millisecond, the email notification service. And if I'm going to add throws to the declaration, okay, and if I'm going to save this. So now you can see if this service, which is the email notification service, is behaving a little slower, that will not impact the user registration service. So I will go to the user controller, and let's say over here, I can just have two sysout. Okay. In the user controller, I'm going to say data saved to DB. Okay. And this is coming from the user service. Okay. And I can have one more println, event sent to the Kafka broker, right? If I'm going to do Control S, this is also going to up and run. So let's say if I'm going to send a new user, if I'm going to create a new user right over here right now, if I'm going to do send, see user created. Now, if you're going to see the console, see right now it is sending the email. So let's just do it one more time. Okay. If you're going to do send, you can see user service data saved, event sent to the Kafka broker, but the email notification service is slow. Right now it is sending the message after 5 seconds. So the slowness of the other microservice is not bothering the user service. And that's how the event-driven microservices are working. The communication is happening based on the events which is getting triggered in your producer application. The producer application sharing that event to the broker. Then from the broker, the consumer application is fetching the event and taking the necessary action. And here is another important thing. What about, as I said, if you have a new consumer API that you need to create? Let's say your company said that, okay, right now you have an email notification service, but right now we also want to send notification to newly created users through SMS. We want to greet them with an SMS. Then how can you do that? Well, let's say simply, if I'm going to do Control C, Control V, let's say you have a SMS notification service. I'm going to do enter, and I have this SMS notification service right now. So I'll remove this controller package of the SMS notification service, not needed. Now, let's just say here, the name I will change as SMS notification service. Okay, now everything remains same. Let me just remove the thread.sleep from here. And everything remains same. You can treat this class right now, SMS notification service application, is a separate microservice. Okay, and once this is up and running, we can keep listening to this topic. If there will be any user events will be fired, then we will be consume that username from that topic, and they will be arriving as string format. I'm going to change the method name as send SMS. Okay, and I'm going to change the group ID as SMS group. This is a consumer group basically. I'm going to change it as SMS group. And maybe I can just do a little bit of tweak over there. Here, I'm going to change this group ID. It could be anything, but I'm going to say email group, not email service, by the way. Let me close this. And let me go to the SMS notification service. And I'm going to say sending SMS to the username. Okay. And there you go. So I have another application right now. So let's start this application also. Right. Oh, I need to change the server.properties. I'll go to the resources, application.properties. And here I can make it run in 1995 port number. And let's just start this application. Okay. Can I go over here? start this microservice as well. And this is also up and running. Now, these are my consumer microservices, okay? And this is my producer microservice. When it produced the data, both SMS notification service and email notification service will be consuming the data from the producer whenever it is going to push data to the broker. From the broker, these two listeners are there which will be listening to the event. Now see, I haven't made any changes to the user service. If it is REST-based call to these applications, then I need to introduce new REST endpoints over here inside this service in order to make call to the SMS notification service. But right now, everything is asynchronous. Here from the user service, if you're gonna see, if you're gonna go to the user service right over here to the controller, right over here, we are not making any REST call. If we are making a REST call, then here we need to make a REST call to the SMS service. We need to make a REST call to the email service, and there will be tight coupling with the user service. This controller exists inside the user service with the other two services. There would be pretty much tight coupling. So if you're going to be doing any new API call, then first of all, there will be tight coupling and it will be synchronous because we'll be keep waiting for the response once we hit the microservice. But right now, you can see we just need one more service we just created. We haven't made any changes over here and all of our microservices are ready. And we just created this service and that's it. We haven't touched this, we haven't touched this. And that's what microservices basically encourage. And right now, if you're gonna fire a request, let's say I'm gonna do a send, okay? You can see SMS notification service is sending SMS to this user and email notification service is sending email to this, okay? So this is it for this video. There are already so much of information, so I have to cut few points. But you can already see what kind of problem the message-driven microservice is solving. And actually, if you want more, we can add on a lot of different things with this project, and we can go with a little bit of to the complex side. We can bring in the topic creation using Spring Boot, the topics with partition, the in-sync replica, and maybe the key value pair message sending, and a lot of other things like fault tolerance. What will happen if there will be exception will occur? A lot of different use cases we can put it over here with this particular project. So if you want the part 2 of this, let me know in the comments so that I can go ahead and will create few more videos in this particular series. And just let me know in the comments if you need the part 2 of it. And part 2, part 3, part 4 of it, by the way, or at least one more part, we can complete this project. But I will only do it if you are actually going to let me know in the comments that you need that. So give me a like so that I can understand that you are liking this video. You need more videos like this. The second thing, we can discuss more about the event-driven architecture, the pros and cons that it adds. For an example, here I haven't talked anything about the scaling. The event-driven microservices are very easy to scale compared to the REST-based microservices. I haven't talked about it. So just remember one more point in your checklist that is very, very easy to scale whenever you are using Kafka. So yeah, we'll talk all about these things in next video if you want. So make sure to do practice, do hands-on. And, if you have any questions, drop that in the comment. And if you want to learn more about the Kafka, I have a playlist. Keep watching all the basics of Kafka so that we can implement all the other stuff with Spring Boot straight away with the next video. So this is it for this video. I'll see you guys in the next one. Till then, bye-bye, take care, and happy coding. See you guys and take care.